Antares was supposed to be a reliable workhorse, delivering cargo to the International Space Station, but in 2014, just 6 seconds after liftoff, a turbopump failure threw a wrench in plans that NASA surely didn't budget for. This malfunction sent the rocket hurtling back to the launch pad in a fiery explosion reminiscent of the grand finale at a fireworks show, except nobody was cheering. The blown-up rocket and cargo cost about $80 million, a staggering sum that made taxpayers blink twice and Orbital Sciences rethink their engine choices. The engine in question was a repurposed Soviet relic, originally from the 1960s, which sounded charming until it turned on NASA like a vintage car that spontaneously combusts. This failure forced NASA and Orbital to reconsider every bolt and pump, triggering upgrades that made future launches less of a nail-biting gamble. So, the lesson stands clear. If you're relying on engines from the Cold War era, but hey, at least nobody was on board to test if Fireball travel was a viable new space tourism option. If you think this was the last time rockets would embarrass themselves, buckle up, because what comes next involves a pilot grabbing a tiny rocket and fleeing for his life. Later moonlighting as a space launch vehicle, but its 1958 test launch was anything but smooth. Moments after ignition, the rocket shuddered violently, but refused to take flight properly. With the situation deteriorating, the pilot did what any reasonable person would. He hit the eject button and rocketed away in a mini escape pod. Minutes later, Atlas transformed the launch pad into a spectacular fireball, taking with it millions of dollars in equipment and dreams of easy space access. The emergency escape system proved effective, but the event highlighted just how dangerous early rocket tests were and how little room for error existed. Watching this unfold was the earliest evidence that spaceflight required more than just raw power. It demanded precision, bravery, and just a hint of divine intervention. Surviving pilots? Check. A fiery disaster visible for miles? Double check. The real question, could this story get darker? Spoiler alert, it did. January 28, 1986, dawned cold over Florida, but the excitement was hotter than ever. Challenger, NASA's trusted space shuttle, prepared for liftoff with 7 astronauts aboard, including Krista McAuliffe, set to become the first civilian teacher in space. The world watched live, hearts pounding, as Challenger soared into the sky. For 73 seconds, all seemed perfect until disaster struck. A rubber O-ring intended to seal parts of the booster rockets failed in the freezing temperatures, allowing pressurized hot gases to escape and ignite the liquid fuel tank. The shuttle disintegrated spectacularly in mid-air, witnessed by millions. This catastrophe reshaped NASA forever, exposing systemic flaws in risk assessment and communication. The Challenger disaster wasn't just a technical failure, it was a profound human tragedy, a stark reminder of spaceflight's cost and the price of complacency. This was a failure witnessed live, but rockets aren't only felled by rubber rings. Next, meet a missile system that couldn't even hit liftoff reliably. Imagine a rocket so unreliable it earns a nickname like the guided missile that lost the guide. That was Juno 2, a 1950s-era U.S. rocket built off Redstone technology but plagued with failures. Out of 10 launches, 6 were abject failures, often failing spectacularly right off the pad. One particularly catastrophic flight in July 1959 saw Juno 2 veer sharply off course seconds after liftoff, thanks to a short circuit that knocked out its guidance system. What followed was a fiery crash and a $10.83 million loss as the rocket ignited the launch pad in a blaze that made onlookers rethink their career choices. This disaster marked a dark chapter in early U.S. space exploration and forced engineers to rethink navigation redundancy and system robustness. While Juno 2 was shelved, its failures taught lessons still etched into modern launch protocols, because apparently, rockets really do need someone to tell them where up is. If you're wondering whether any of these early rockets might actually succeed more than they fail, The Titan one will leave you wondering if mostly reliable is a compliment or an insult. Titan 1 was introduced as the dependable successor to Atlas, a rocket meant for serious payloads, ready to make the leap beyond shaky predecessors. But early models were anything but reliable. In 1959, one unmanned Titan 1 barely managed to clear the pad before detonating into a $12.6 million fireball, a dazzling event that forced contractors and engineers to rethink rocket design and safety protocols from scratch. The lessons learned: redundancy matters, wiring must be shielded, and remote destruct mechanisms are non-negotiable. Though later models improved, early Titans earned a notorious reputation. Proving mostly reliable is not the boast engineers want beside their names. These fiery failures were brutal reminders that unmanned doesn't mean unimportant, and that every rocket is just one twisted wire away from performance art. If rockets running in the same family are failing this drastically, what about the grandfather prototypes? The Atlas of 1957 did something special enough to deserve a highlight reel. December 1957 was a defining month for the Atlas family, America's first large-scale ICBM. Testing new limits, this prototype launched with high hopes but showed all the grace of a gymnast gone rogue. Moments after liftoff, the rocket flipped violently and plunged back into its own plume of fire, destroyed by a rapid thrust imbalance. The destruction was swift, and a remote destruct system prevented further damage on the pad. Engineers scrambled to analyze why the boosters couldn't stabilize the ascent and found structural weaknesses and overtaxed propulsion. This dramatic failure was foundational. It forced radical design changes that saved future missions. The Atlas's spectacular crash was a baptism by fire for American rocketry. Painful, costly, but critically educational. But let's pivot from steel and explosions to software, where invisible errors can craft disasters just as devastating. SpaceX's Falcon 9 had revolutionized spaceflight with reusable boosters and ambitious goals, until 2015 reminded everyone that rockets don't care about buzzwords. After an initially beautiful liftoff, the second stage ruptured in mid-air due to a broken strut holding a helium bottle in place. This failure caused a chain reaction. Tanks ruptured, fires broke out, and $62 million worth of cargo and vehicle debris rained down. The culprit? A tiny piece of steel that didn't meet spec. A humble reminder that space exploration is a game of flawlessly fitting puzzle pieces. Elon Musk publicly admitted the failure was a harsh but valuable lesson, forever tightening quality assurance policies. The incident highlighted human fallibility amid aerospace ambition and underlined that innovation often burns brightly, sometimes literally. If human error trumps metal failures, what happens when new generations of rockets face structural collapse from invisible forces? The Atlas Centaur in 1962 provides a dramatic answer. The maiden voyage of the Atlas Centaur, designed as the heavyweight champion of payload delivery, ended catastrophically 60 seconds into flight. A sudden loss of pressurization in the liquid hydrogen tank caused the tank to implode, rupturing fuel lines and structural components. The rocket broke apart mid-air, turning $70 million worth of hopes and hardware into debris scattered over the Atlantic. The failure exposed critical engineering oversights: thin tank walls that collapsed without warning and insulation, failing to protect vulnerable components. Subsequent investigations were intense, resulting in redesigns that transformed how pressurization and tank integrity were managed. This disaster remains a classic case study of how the tiniest structural weaknesses can fatally compromise the most complex machines. Now imagine a rocket that manages to fly, but decides life is just too hard after barely lifting off. That disaster takes us to Atlas Centaur 5 in 1965. Confidence was high for Atlas Centaur Model 5 following a series of earlier failures. The rocket roared to life and managed to lift off the pad, but scarcely a few feet in, the engines unexpectedly shut down. Gravity immediately reclaimed the reluctant vehicle, which crashed back onto the pad and exploded. The blast obliterated the rocket and any hope for a clean mission, with the financial toll still officially classified, adding an extra layer of mystery to this spectacular flop. This failure underscored just how delicate the transition from prototype to reliable launch vehicle was. Post-incident reports led to enhanced diagnostics and remote shutdown procedures, improvements that would be woven into future rockets' DNA. The takeaway? Space launch doesn't forgive false confidence, and even a few engines going silent early can turn millions of dollars worth of ambition into ash. If you thought the Americans had cornered the market in disastrous displays, you haven't seen a Russian Proton M dance on the launch pad. The Russian Proton M rocket's 2013 launch was an anti-ballet of calamity. Seconds after liftoff, the rocket inexplicably tilted far left, corrected violently right, then swirled in a dizzying loop like a badly programmed drone caught in a hurricane. The chaos unfolded thanks to 3 gyroscopes installed upside down, a simple, spectacular human error turning multi-million-dollar tech into tragicomic debris. Mission Control could only watch helplessly as Proton M spiraled off course and crashed near the launch site, igniting a toxic inferno and destroying its valuable payload. No cosmonauts were on board, but the financial and environmental fallout was enormous. This fiasco coined the phrase "proton moment" in aerospace circles, a reminder that even high-tech marvels can fall victim to the simplest mistakes. What do these disasters teach us? That the universe is as unpredictable as it is vast, and no matter the technology, spaceflight is always flirtation with the unknown. Thanks for soaring through the most jaw-dropping rocket disasters with CosmoBinge. Please subscribe for more cosmic chaos served up regularly. Drop a comment telling us which explosive fail made your hair stand on end. Smash that like button to keep cosmic calamities coming. And remember, if your rocket doesn't blow up, did you even launch?